That's right. That was a good intro. Okay, so the first thing I'm going to do is I'm going to draw this guy just so that you guys can see the whole aspect of it and you can follow along here, okay? So the truss itself, you start with A. Obviously, there's a D, there is a C, there is a B, and then it connects to create this truss. 3 feet is over here. These are just givens on what you have. 6 feet is here. And then this is a roller. These are all the givens that you need, and a pin. I think that's all they give you. B is obviously up here. Okay. Good to go. Oh, yep, you're right. 26.565. Those of you guys who are working on 4, I have the answer key done too, so I'll give it to you later, okay? Good to go? Okay, so if we look at this and we step this very first thing, look at step 2, okay? Do you guys need me to zoom in a little bit so you can see it? Is that better when it focuses? Okay, better? So in this case, you're going to see step 2 is using the formula 2J equals M plus R. What does that mean? And again, I'm going to make this very elementary so we can explain this. I can't break it down. Those are rollers. That means it's a roller. We're not there yet. You guys are way beyond where we're at. Okay, I'm going to explain each piece. So 2J equals M plus R. Micah, you weren't here, so you're really far behind. We got to just get you caught up, okay? 2J equals M plus R. J means joint. Basically just means where these things connect. So in this case, there are 4 of them, right? So 2 times 4 equals the members. Now the members go from each letter. We'll see in, for example, number 4, when we get to the 4th truss, that there are, it looks like there's one big member, but if they're separated by a letter, those are 2 separate members. I'm not getting ahead of myself, but DC, CB, BA, AD, and DB are all members. They're all just connected lines. Those are supports, members. So there's 1, 2, 3, 4, 5 of those. Plus reaction forces. Micah, you just asked what these circles are. These circles represent a roller and a pin. All that tells you are, there's a couple things. The pin tells you where the pivot point is. The second thing it tells you is how many reaction forces are acting on each one of those subjects. So if you have, for example, a pin, you will always have a reaction force in the X and in the Y direction. In this case, we have a roller, and that is going to have 1 in the Y direction. All you need to understand is that a pin has 2 reaction forces, and a roller has 1 reaction force. Go ahead. Sometimes they're switched like this. Sometimes they're switched like this. This is basically hanging from a cliff. It's coming off of that like a drawbridge. I'm guessing right now. Yes. Okay? How am I guessing? I have to have an educated guess here. Here's where I'm going to guess from, Rudy. Good question. I have a negative 75 right here, right? Going down. That's why it's negative. What only force in the Y direction as far as reaction forces are opposing that one? This one right here. That is reaction force A in the Y direction. That makes this one reaction force A in the X direction. That makes this force reaction force D in the X direction. Knowing that this is opposing, Rudy, you asked why I went that way with the arrows. If this is going down, this has got to go up. Okay? This one, I'm kind of guessing, just I know that they're going to oppose each other. That's all I know. Okay? So, the next step is to basically go off of that and to label my unknowns. And my knowns, I should say, both. So the first thing I'm going to label is the force 1 that they give us. These are going to be 75 pounds, or this is going to be 75 pounds. And this is going down in what direction? Y direction. Next one I see is R, reaction force, A, in the X direction. The reaction force, A, in the Y direction. Reaction force, D, in the X direction. These are all things I got to solve for. Yes? Correct. This is in the negative Y direction because it's going down. The reason that should look something like, you know, I drew that chart before, but I'll draw it again here. This is obviously positive X, positive Y, negative X, negative Y. We need to indicate the direction. Yes, sir. I'm sorry. Good question. Good point. So I started on these points. Yeah. These are 2, and this has 1. So reaction forces 1, 2, 3 reaction forces, 8 plus 8. That checks out. We're good. Okay? Now, beyond that, we need to find, those are the external forces, what I just wrote down here. Now we need to find the internal forces as well. Internal forces include forces AB, right? AD, BC, BD, and CD. And we're going to find out whether they're in compression or tension. I told you before, compression means what? That is pushing in. Tension is pulling out. Okay? With that being said, it's the opposite of what you think it should be with the arrows. Why? Because it is what the force is acting and opposing against. So if the member is in compression, then it has to oppose and the arrows are going to go out. It's indicating where it should have to oppose. So compression, the arrows are going to point out. Tension is going to point in. Yes? That's all I got so far. It's just this. Okay? So now I'm done with the summary box. I'm done with step 2. I'm done with step 1. Okay? Yes, Smith? Tension. So if I scroll up a little bit here, step 3 is to solve for the external forces. If I zoom out, I'll zoom out for you. Here we go. If I look at the external forces on this, just the outside forces, okay? The sum of all of the moments are equal to 0. In this case, it indicates right here, and it says joint. That means, basically what I do as a rule of thumb is I look for where the pin is. That is going to be the rotation angle, or the point, on where all this is going to rotate from. Okay? I usually use this because it has 2 reaction forces, which means that thing is not going anywhere. That is my starting point for my moments. So using that, I'm going to say that joint A is going to be my go-to. Okay? So the sum of all the moments equals 0. Moments are force times distance that is perpendicular to that force. So if I'm starting from here, basically I'm starting from this side in retrospect. Okay? If I'm starting from this side, what distance do you want to start with? Well, I would start with the 6 here because it's starting from this side. 6 is my first distance. What force is perpendicular to 6 as far as external forces go? 75. What did we say if that was negative or positive first, though? So we're going to say 6 times negative 75 is our first moment. And we're going to add all of our moments up to equal 0. From there, we still have this side here. Okay? This also, from this point, is basically going in both directions. So now we have this 3, right? This is the other distance. What force is perpendicular to this 3 starting from the top, going down? What force is acting against that perpendicular? RDX. So we have 3 times RDX. Are you with me so far? For the sake of time, I've already done all these answer keys. So it's negative 450 here plus r dx, or 3r dx, equals 0. I add that to the other side. My final answer for the reaction force at the dx is 150. Okay? I'm also going to put that up here. And because it was positive, it is going in the positive x direction. And I guessed right. Rudy, did you see why that stays that right now? Now, knowing that, and knowing basic physics, opposing forces have to act to equal and to basically submit an object to stay still, right? Or to just oppose to stay consistent. If this is going this way, the opposing force that is in the same direction, what other force besides the reaction force in dx as far as externals go is going in the y direction? RAX. Okay? That's the only other thing. So in theory, we know, I'm going to prove to you, but we know that that's got to equal a negative 150 because it's got to oppose it. Right? I'm going to prove that. So what is the sum of all of the forces in the x direction? So what's in the x direction? Well, RAX is in the x direction. RDX is in the x direction. Right? And that's equal to 0. What does RAX equal? RAX, we don't know. But RDX is 150. RAX equals negative 150. Negative, meaning that this direction should be going to the negative y. There are no negative answers. So this is still positive. This is going to be positive up here for RAX, but that indicates that it's in a negative x direction. Go ahead, Hubert. I apologize. Yes, these are all in pounds, right? Okay. Good. Now I'm going to prove beyond that the other ones. So now I got, RDX, RAX. What am I missing as far as reaction forces? RAY. So what is in the y direction? We have a negative 75 because it's going down, plus RAY, which we don't know, is equal to 0. RAY equals a positive 75, which then indicates that that positive is going to go up, which makes sense because they're opposing each other. So that's going up. It's a positive 75, and it is positive y direction. With me so far? Mrs. M wants to still focus on this step 4. All you need to know, okay? What is, in basic geometry, what do we know as far as a proof? What is this called? Congruent, what? I don't know what the thing is called. Alternate interior angles are same, right? Congruent. That's all you need to know. Okay? So that means that this is 26.565. That's all, the only rule you need to know. Next. We're good. This page is done. With me so far, any questions? Now we have the external. We have our moments. We're going to solve for all these other forces here. Okay? So we can keep these alive and still showing, I'm going to show all these up here at the same time so you guys can see where we're going with this. Okay? So the key here, a lot of people skip this step and they're like, I don't want to redraw this. I'm telling you right now, this is going to simplify the whole process. It's going to break it down, because if I draw what I'm about to draw, you're going to freak out on me. So I'm going to start with A, and I'm going to say A has a reaction force. We proved all this. RAY. It has a RAX going this way. And then we are going to guess, right? I'm going to guess. I'm going to say that this is going to go in. That's AD. Why am I guessing that way? Because we know if it's going up, this is probably going to go down, right? I'm hoping. Goes into D. We have an RDX here. No force acting down because it is a roller, and this is my conjunction here. We have a force, and I'm thinking that this is going to go in. Again, just a total guess. goes over here to B, and over here to C. I'm going to say, because this is a force acting here, this is force, I'll call it 1, equals 75 pounds. I'm going to say that these are going to go in, and this is going to be CB, I think is what I called it, BC. I want to keep that consistent. This is going out, so I'm going to guess that this is going to go in, and that's going to be my AB. I'm going to write this theta in here, which is going to be 26.565. And then I'm going to say if this is going in, these should probably go out, right? I'm hoping. And that's going to be my CD. Am I missing anything? Yes, no, maybe so. Good to go? Okay, so that part is pretty good. We're good there. We're done. What I want to focus on first is, how do I explain this? You're going to be jumping around a little bit with these next steps, okay? I'm going to come back to these just because now we have what we need. So you're going to be jumping around a little bit because sometimes you might have enough information. We got to kind of guess on where we want to start with this. I'm going to start with C. Why am I going to start with C? We have a given that we know is correct, okay? And we also have only a couple forces that are straight up and down, which to me are pretty easy to solve, okay? So in this case, if we know r dx, right? What was r dx as far as an answer goes? R dx was 150, right? R ax was also 150. If you have 150 and 150 acting against each other, right? What should this other opposing in this direction here? If this is going 150, should this one go in the opposite direction as 150? It should just stay what it is. I'm going to prove that later. We're not going to worry about that right now. So let's start with C, and we're going to try and solve for DC. Yes, ma'am? It's not negative because even the only thing that negative did was created this negative x direction. It didn't make it the number negative because a force is not negative force. Okay? So from there, we're going to try and solve for FDC or CD. And we can't because in the direction in this case is positive 150. We'll get back to that later. So let's do the y's. What is in, and we're going to draw this. Oh, CD, sorry. Goes in, goes up, and this is only at point C. And it goes down 75. BC. Right? BC. So from there, okay, you have what is in the y direction. We have BC plus a negative 75. And that's equal to 0. So if you do the math, obviously BC equals a positive 75. Okay? So BC, I'm going to write that over here, is a positive. If it's positive, we guessed correctly as far as the arrow direction in here. So BC is right here. We guessed the direction right because the answer was positive. We're good to go. Yes, Hubert? So it is in tension. Good. Okay? We're going to go back to this later. But I can prove in this case, if this is 150, this is 150, CD is going to be 0. I'll prove that later. But basically what we're going to see from here on is we're going to go into point A. And I'm going to draw point A. You go up. Point A is here. We have RAY. We have RAX. 150. What was RAY? 75. We have a force going down, AD, which we don't know. We have a force going in, we hope, which is AB. Okay? So in this case, let's try and focus on the things in the x direction first. The x direction consists of RAX and AB. And they're all going to equal 0. Is there anything else in the x direction? No. Pretty self-explanatory. RAX is a positive 150. I'm sorry, a negative 150 because it's going backwards. Now, Smith, this is where it might get a little confusing, right? it is a positive number, but because it's a negative x direction, it makes it negative when you're doing the math. When you're showing the answer, it's positive, though. Okay? So in this case, you got a negative 150 plus AB is equal to 0. AB equals a positive 150. What does that positive number indicate? We guessed right. Good, Ed. So AB in this case, these arrows stay the same. And again, Hubert, tension or compression, bud? Yes? Because you don't, I got to prove through math whether the members are in tension or compression. Why bother doing that is what you're asking? I don't know. I don't know. Why am I guessing whether it's in compression or tension before I actually calculate it? It just confuses them. They think so. Okay. So we have, in this case, the AB. We're good at 150. Let's do the Y's now. So what is in the Y direction in this case? RAY plus AD, and that equals 0. We do know that it is in positive 75 for RAY. We do not know AD. That's what we're trying to figure out. It equals AD equals a negative 75. As Miss M likes to say, uh-oh, we might as well give up because it's a negative number, right? That is incorrect. No, you do not give up. If it's a negative number, what does that mean? So we did this guessing wrong here. Does that, Smith, mean that we put a negative 75 up here? No. It means that we change this to going out and that we say it is under, Hubert, compression. Okay? Next, we're going to go to joint B. We have joint B up here. We are going to show that this goes down to create BC, goes over to create AB, and then goes in to create DB. Now, with that being said, okay, there's a couple other things, and this is kind of where we start getting lost. Up and down stuff is pretty easy, we've come to realize so far, right? If you have an angled vector, you have to show where that supports. My best explanation for that, if you 3D print something, can you 3D print something in mid-air? The answer is no. You have to create a support for that angle. If I'm creating an angle like this, I have to have a support. To show the math and to prove the math, I have to create basically what you're seeing in the video, a right angle, a right triangle. So, under B, to figure out what DB is, I have a Y and an X. This is DB, this is DBY, this is DBX. Okay? So let me zoom in so that we can see that, because I don't want you guys to get lost here. Math gets a little bit touch and go. So we have X in this case. Let's start there. We have all of our forces. What is in the X direction? And this is where we start missing things. What is in the X direction? What's that? 75 is incorrect. What is in the X direction? Okay, so DBX, right? So we'll say DBX is first, plus what I heard over here? 150. What is significant about that 150 if you look back over here, though? So, negative 150. Okay, with me so far? And that is all equal to 0. Did we miss anything? That's AB, right, and DBX. Those are the only two things in the X direction. So now from there, that is DBX minus 150, which then turns to make DBX a positive answer. That means our DBX, okay, is going to stay where it's at. We're all good there. We got DBX to equal 150. Okay? Now, one thing that might mess you up a little bit here that I just thought about just now, you could do a couple things here. You could cheat. You could do a couple different things. If I wanted to, I could also draw this vector like this. Right? So this is dbx. This is dby. And this is still db. Does that change anything? That doesn't change anything. What it does help me with is the fact that my theta, which was up here, is now here, right? Which causes it to be where I want it to be right here. Does that make sense? Okay, so I'm going to use this version just because, and I should have used it from the beginning, I apologize. I'm going to use that version just because it's easier for me to explain. So in this case, dbx is 150. My theta is still going to be 26. Theta is right here. 26.565, right? Knowing that, what can I use to solve for my BD? Because that's the whole point, is to try and solve for this DB, right? This is my hypotenuse in this sense, right? Which is what? Cosine. So cosine theta adjacent over hypotenuse. In this case, our theta is the 26.565, and our adjacent is actually what we're looking for, correct? No. What is our adjacent? 150. What is our hypotenuse? What we're looking for, which is in this case dB, right? After you rearrange the formula, for the sake of time, dB equals 167.705. And all I did was multiply by dB, what I do one side or the other, and then divide by the cosine of 26.565. And I can even write that over here. So after I do cosine 26.565 equals 150 divided by dB, multiply by dB. What you do to one side, you must do to the other. That gets rid of this over here. Divide by the cosine of 26.565. What you do to one side, you must do to the other. That gets rid of these. You're left with dB. You punch that in the calculator, your answer is going to be 167.705. Now I wrote that in the y because do we figure out dB? Did we figure out AB? Did we figure out BC? Those are all done already, so we don't need to do anything other than that. So our C, we just figured out dB. It was BD up here. It's 167.705, and again, that was positive, so we're good. We don't have to worry about our arrows. We were correct on that. And now, I'm going to go back up to the very last one, which is CD. If you have an opposing force going positive 150 here, negative 150 here, is there any stress or strain on this? No. That's it.
How do you get there again?
If you have a opposing force here and a going in, out here, what force is acting on the base? None. Yes?